careful and filtering in the way, and you are seeing the raw application directly, and you have accountability to the user directly, which is really good. We're doing our challenge today. Well, I'll go into the content of it in just a moment. Do we have any participants who wish to present on the challenge?
I can.
Brad says he is in on the deal, so that is very good. Anyone else to participate on the challenge?
Well, I sort of did a riff on it. I was going to just include that in 5 minutes of my talk, but because it's sort of more at the upper large scale end of things, but I don't know whether I want to include it now.
All right, let's move along on that, and that's good. So first, let's go to Brad, and you have control, Brad.
All right, can you see my screen? So apologies for the rough shape of it. I, as often, did not have any time beforehand, but here's what I've done. So I went ahead and sort of two goals.
Brad, let me interject here before your presentation. For the people not familiar with this week's challenge, this is a derivative or a bit of a Wordl toolkit. I'll talk much more about Wordl in my presentation, but the challenge today was to develop a list of 20 each of 5-letter words, and then develop the cumulative frequency of the letters in each word. So if the letter was all E's, the frequency would total to 11 because it's 11% of English words use an E. And so this will be a little stepping stone on which words have the highest coverage to English language letters. And now back to Brad.
Cool. Yeah, so I decomposed this sort of in 2 ways, and I'm embarrassed for the redundancy here up top, but the shortness of the time, I pulled in to get letter frequencies that, I thought, well, rather than consult some table, I would just take a look at the Unix word list. There's a standard file on Unix systems that contains a list of English words. And using the standard ANS words, I go ahead and read that entire list of words into memory. I also read in my list of 20 words that I just manually picked from it. I didn't manually pick them. I found some website that said here are 20 good words to use for Wordle. So I thought, well, I'll pick these 20 words and use them as my input. I load both of those into a buffer in memory. And then I constructed a different kind of looping primitive that lets me loop over a list of words. So it basically can walk down a list of carriage return terminated words and finds each word. And so you're able to have this each begin and end sort of looping structure, which we can see down here. For example, if I want to loop over the letter frequencies, I can pass in a list of words, loop over each of these, and then what's left on the data stack at each step is the counted string for each word in that list. And then I build up a table of letters, and I accumulate into that table of letters just a count. So when I'm initializing the frequencies, I just go ahead and increment the count for each letter in a word. And I've got a printing word that prints the frequency divided by the total number of letters. I'm also keeping track of the total number of letters, like I can do this all in integer. I've got a word that lets me print out the table of letter frequencies just to make sure that they make sense. And then for a given word, I'm able to loop through and use my letter frequency table to accumulate its frequency. This is the integer frequency that still needs to be divided by the total number of letters in that English dictionary. And then the sort of the overall structure of the thing is that it goes and calculates that table of frequencies, prints the table, prints a new line, and then loops through each of my 20 words, prints out the word, and then calculates the frequency for the word prints it out. So we get this table of letter frequencies. It isn't a spot-on match for the frequency table that Wikipedia has. I suspect that some of this is counting, the frequency of words in the dictionary as opposed to the frequency of the words in some corpus of English language, but it's at least in the right ballpark. That 11% Bill was mentioning. It's a little below that. And then for my list of words here is the tally. It sounds like, Bill, though, you were intending for a division by the number of letters in the word. So I might be, there might be a divide by 5 that's missing in here. But back to you, Bill.
Very good. Absolutely great. Just exactly what I intended. And now, Bob, could you give me your comments there? And again, remember, we're time limited, so we'll make it direct.
Bob, we don't hear you.
Bob, you're muted.
Okay, Bob, to unmute.
Okay, I'm unmuted, sorry. Oh, I just came over here to, I'll skip because you've got the visual. But in any case, I was reading this and this thing on fourth. Let me go. Why is this on top? Let me get here. I'll even just move this over. Back, here we go. No. Why in the world is this? Let me just hit this again. There we go. Here's in any case, I just pulled this into Cozy. It's 2,900 characters. I went and replaced it, turned it into words. I eliminated all the things that were not letters, converted all to lowercase, grabbed all the five-letter words out of that, split them in here, all the words that had happened to be in there. And I went through and just did a couple of things to go and find out how many letters, how the letters showed up and so forth. But then a while later, it just struck me, I got interested. I actually found that there's lists online of the entire Wordle list. It's got here somewhere. And anyway, I pulled that in, and that's got, I remember 77,000 characters or so. It's a list of all of the five word legal Wordle words. And boy, do I not give a damn about Wordle. It's just not my sort of thing. But in any case, I went and have a couple of words here. One of which is actually very similar to words that were actually rather late in creation by both Iverson and then a grouping word by Whitney. But in any case, gets down to this line here, which goes and for all of those 77,000 letters, it goes and determines the locations. When I strung it out, I strung all the words out into a long vector, long list. For each alphabetic character, and I found out that, anyway, they're all in there. This actually, I'll say, was slow. But then actually I turned that into, I did POT is one of the word I've had for a long time, and it's proportion of totals. So that just goes and it turned these frequencies into totals, and I sorted them by frequency and so forth. So here's the final table of all legal Wordle words and their frequencies. So E is the most, then S, and then A, and it gets down to Q is the least common, only 112 occurrences in all the legal Wordle words. So that's it. And let me unshare. Unshare. Oh, and stop share. There it is.
Very good. Thank you, Bob. It's always interesting to see the variety of approaches that people use. And now, very good. Okay, here is my offering on it. The challenge for today is, as I just stated earlier, is to guess a 5-letter, here's the definition of the Wordle game. The Wordle game came about last November from its public release from a fella in England. He and his girlfriend developed this over several months. It caught on like wildfire, and the New York Times purchased the rights to the game for the low 6-figure number. So somewhere in the $2 million, $3 million range, he sold the game. He said, I do not want to maintain it. I do not want to live with it. It's a creation, and he passed it on to the New York Times. So the essence of the game is you are obligated or expected to guess a 5-letter word. You have 6 tries. The display will give a gold outlined letter if the letter is used in the word, and you will get an outlined letter in green if the letter is in the word and it's in the correct position. So people spend time trying to find the magic first couple of words to start with. There are 2 strategies I've determined. One way is to start with a single word, whatever it is. Guess a word, and then once you have that word, you examine it and you see any letters that are correct, and then develop another word, always including the correct letters. When they show in green, you have new words that have the letters continuing shown in green. So you iteratively approach, and so people will pick the first starting word, and a do is one that is taken very commonly because it has a lot of vowels in it. But this is the iterative sequential approach. Another approach is to pick a couple of starting words that are mutually exclusive. In other words, the first 2 words have no letters in common. Maybe you have 3 words, no letters in common. What you're really trying to do is determine as many good letters as possible and eliminate as many letters as possible. So in this case, the elimination of letters is key. Then once you've gotten your first 2 or 3 words, then you work on to the known letters. Here's an example of the first case. This one is totally iterative. So I started with the word ridge, and I saw that I and D in gold are used, and E is correct, used in the last position. So I knew my next word had to use I, D, E, and it had to have E in the last position. So I put doggy, and it turned out the D, O, and I are in use, and the E is correct in the end. And but I did not learn anything on new letters, but I do learn correct positions. Oh, actually, that picked up O. So now I know that O is used. 4th line then was I had to incorporate D, O, I, and E and add a letter. So I picked diode, and that met the position rules, but D was wrong because it does not show in gold or green. And then I put oxide in, and it was a winner. Now, this is my other approach. This is my favorite approach for very hard words. And I have 4 words that are mutually exclusive: stare, lucid, and foamy. Across these words, you have 86% of all English letter frequencies. So this will include 86%, and it only leaves you 14% of the letters that are unknown. So from that sequence, I went directly to diode because it anagrammed the I, O, D, and E, and then came up with oxide as the winner. So our 4th challenge today, as I mentioned before, is to develop a list of 25 words and then calculate the summation frequency of letters on the words. We're looking for words that will be most useful. The logic of my program was, first, you'll see in it, I declared the data structure. I loaded 20 words. I then created a frequency table, which I copied from Wikipedia. I initialized my output variable, and then I scan across each of the 20 words and sum the frequencies. Very logical, very simple. Some of you have seen my matrix extension for 4th. I used it in this case, using it for characters. So this words left brace declares a variable named words. The left brace square bracket quote is a word which scans ahead and pulls in the proper number of strings. Each string is ended with a double quote. So you see my words stare, lucid, foamy, and so on. This was a formatted output, so I could take a quick look and see that my words were properly accepted into the system. And then the frequency table. Now at this point, I'm going to floating point, and the first letter of the 65 is the decimal value of ASCII A. So I'm working in decimal in this case, and these go into floating point matrices where for each letter I have its frequency of occurrence. To output the letter tables for a check purpose, we see that E has approximately 11% of the English language letters, and over at Q, it's 0.2%. This is my frequency accumulation word. This does all the work. It's all here. On the first line, it says result matrix and clear it. Then we take the words matrix, find its dimensions, and determine the number of rows. We take the words matrix dimension again, find the number of columns, and we set up the frequency table, and we get its number of rows. So I have 3 nested matrices. I'm going by row, by column, and then down the frequency table by row. The next little segment says select a letter from words, look it up in the frequency table. Select a letter from the words, select a letter from the frequency table. Are they equal? If they're equal, extract the frequency and then sum it into the result. So this executes with nested loops. It shows the brevity of 4th. I'm not that familiar with other programming languages, but this is something that would take a page or page and a half of code, probably. Here's the result. The first word that I use is stare. I like it because it has S, T, and A, which are commonly used vowels, and A and E, which are commonly used consonants, and it's A and E, which are commonly used vowels. And that one word covers 40% of the English language frequency. Lucid adds 24%, foamy adds 19%. So between those 4 words, we cover 86% of English. And the other words are in there for curiosity. The hardest word I found in real life in Wordle is fjord. There is an application online that takes the Wordle game and opens it so that you can select any game by game number over the last 6 or 7 months, and you can play individual games. So I started at Wordle number 1, and I've actually played all about 205 games so far, working through every one of them. And fjord was by far the most difficult because it only has 1 vowel and it uses F and J, which are very less used words. This has taken over our first 15 minutes every morning. My wife and I play the game, and then we get on text and we go to relatives and see who's gotten which word and how hard they were. So that is my presentation, and I can accept any brief questions. Come now. Very good. No questions. I'll turn it back to Kevin, and thank you very much for. Oh, one more. We'll go back again. You don't get escape this way. Here is next month's problem.
Oh,
So next,
thank you
next
so much.
problem. Kevin loves this because we're a month ahead. For May, now you
Looks
develop
like when
a
I
large
announce
list
the
of
next month's
five-letter
meeting,
words.
I'd like to have the challenge at the header.
Say again?
When I announce next month's meeting, always good to have the challenge leading off instead of my I need speakers.
That's my gift to Kevin. So for next month, also develop a list of five-letter words, at least 20, but preferably very large. And as Bob mentioned, the Wordle list is available. It's about 12,000 words. About 2,500 are actually used in the game, and the balance of about 9,000 are available words, but they're not actually used. They're obscure words. They're not actually used in the game. So develop your list of words. I'm targeting to take the entire Wordle list. In this case, we're building our frequency table. So then determine the letter frequency across all the words, and then compare that with your published resource. And of course, it's already been done. Brad did it as a part of his, where he took the Unix word list on it. So Brad's always a step ahead. But this will be another one. It'll be interesting to see. A good one would be to support this. I didn't add this, but you could sort that list by frequency to look at the most powerful words. So there we are. That's wrapped up. And now we turn it back to Kevin. Thank you.
Thank you very much, Bill. I'd be grateful if you'd email me that PowerPoint slide. Thank you so much. I'm very grateful to Bill for doing the challenge month. But let's move on. Bob Armstrong presented at Functional Conference 2022, and he's going to talk about his talk and give us a link to his video. The link also appears on the meetup agenda for this month's meeting. So Bob, start your timer. You need to stop
Oh, I
no
actually
later
got a
than
timer here.
11:05.
I just set my timer.